Hi, it's Brett. I'm back for part 2 of the Biology 112 Fermentation Lab. So this one is the student-designed investigation, and usually we have a lot of different options for different independent variables to choose to see how that affects fermentation rate. I'm not going to do all of those. It could be things like temperature, or the type of sugar solution, or salt solution, or salt concentration. The one I'm going to use today is temperature, but because this is easy to do with things from my kitchen. So I have 3 different temperature environments. There's a pot of hot water here, a pot of warm water, and then a cooler with some cold water. And I will measure the temperatures in a little while once the experiment gets going. But before I do that, I want all of the reagents, all of the solutions that we're going to be using to acclimate to the temperatures. So the glucose and the water and the yeast, we want those acclimating to the temperatures without the fermentation reactions starting to occur already. So to do that, I am going to fill up some centrifuge tubes with yeast and water, and then glucose. And then I will put the yeast mixture and the glucose in that temperature environment and let it sit for about 5 minutes to acclimate to the temperature. And then we'll put them in the fermentation tubes. And I'm also going to put the fermentation tubes into those different temperature environments. So everything will be at the same starting point when we start the fermentation. So we're going to measure out the yeast and water. And for this, I'm going to do 2 milliliters of water in each tube. And then I'm going to do 6 milliliters of yeast. This was the most effective amount of yeast from experiment 1. I think we can agree based on that data. So we'll add 6 milliliters to each of these. And then for the sugar solution, we'll put those into different tubes, again, so the fermentation doesn't start happening before we're ready for it. And we're going to use 6 milliliters of glucose, just like we did in exercise 1. The idea here is the only thing that is different between these setups is the temperature. I'm going to seal these really well so they don't spill yeast into these different environments. Okay. And we'll add the glucose. Other tube. Okay, is all of the solutions we need. And we'll put these into their environments. Again, I'm having these nice and tight. Okay, so these ones are going to go in the cooler, chill out for a while, and that is going to be tube number 3 as well. So I'm going to put that in the cooler. Looks like I might have slightly too much water in that environment. Okay, these are going to go into the warm water. So that's this pot right here. Those will float, but that's okay. And we'll put the fermentation tube in there as well. I can't get the lid on this, but it's not that much different from room temperature, so I think we'll be okay on that one. And then I'm going to be especially careful with the hot environment. It's that one probably a little too hot for my fingers to stand. So I goes in very carefully with the whole test tube rack, so I don't have to fish those out later. And then I will also put the tube in. Okay. So I'm just going to start a 5-minute timer, let those acclimate, and I'll pause the video. All right, so it looks like it's been 5 minutes here. We are going to assume that these the yeast and glucose have come to temperature. They have equilibrated with their environments. Same for the fermentation tubes. Before I start mixing things and start the fermentation experiment, I want to get a reading of the temperatures. I'm going to use this infrared thermometer. We're going to start with the hot environment. And the water in there is 70 degrees. So it might change a little bit over the course of the experiment, but we'll take a reading now and another one at the end. And we can say it's at least in that range. And the warm environment is at 36 degrees. These are Celsius temperatures. Then the cold environment is 4.5 degrees. We'll round that up and I'll say 5 degrees. Okay. All right, so now it is time to start mixing. I think I will start with let's start with the hot environment. That one's going to be maybe the trickiest. So I'll be extra careful here. The yeast and the sugar, glucose. Okay. I'm going to carefully mix these together, and I'm actually going to mix them together in the tubes here. Just to make it a little easier to do the mixing process. Just invert that a few times. And pour it into the tube carefully. And then get the mixture into the tail of the fermentation tube. Go ahead and add our air bubble to this now. Okay. Okay. Put this back in the hot environment. Make sure the yeast is not going to lid on. Okay. I'm going to leave the lid off because that looks like it's going to spill. Or put the fermentation tube over. Okay. And we'll do the warm environment the same way. And mix the yeast and glucose. Again, get the yeast into the mixture, I should say, into the tail. And then add an air bubble. And mark it. I think here I'm going to call this time 0. Yeah. Measure the. Yeah, it looks like it's still marked in the pot. Just leave it cold. The exact same way. Together. And then we will put these into the cold tube. Okay. In at our air bubble. And make a mark. There we go. No, too much condensation. Okay. Now the tubes are marked, and we will wait until the 5 minutes are up and then measure them. Okay, it looks like it's time to take our first measurement. And since tube 2 is going really, really quickly, I'm going to start with that one. That looks like it is at 33. I'm going to say 34, actually. 34 millimeters. And we'll go over to the hot tube. And that is still, I'm going to say that's still at 0. cold tube I'll bring out of the cooler. This is also, looks like it's still at 0. Yeah. We'll let this go another 5 minutes and take some more data. Okay, we are coming up on the 10-minute mark, and we will again start with tube 3, or I'm sorry, tube 2, the warm one. That is going very, very quickly, and in fact, I have to take it out to even measure it. Looks like, say 79 millimeters. And we'll go over to tube 1 in the hot environment. Still at 0. And tube 3 in the cold environment. And that is also still at 0. We'll let these run for another 5 minutes. And I will pause the video again. Okay, we are at 15 minutes now. And if we look at tube 3, we can see that it is about as high as it, or as low as it can possibly get. The tail of this fermentation tube is almost empty. We'll take a measurement. Looks like 98 millimeters. We'll put it back in, but the next reading probably isn't going to be accurate since it'll have pushed out essentially all of the mixture out of that tail. That was 98. And we will once again measure the hot. Tube. And once again, it is at 0. And the cold tube. Is still at 0. Maybe half a millimeter. Well, we're going to call it 0 still. And we will wait 5 more minutes and take our last readings. Okay, we are coming up on 20 minutes. So again, we'll start with tube 2, the warm one. And as we can see, the mixture got pushed all the way to the bottom. I can take another measurement. Again, it's going to lose accuracy because it's kind of going around that curve. I'm going to call that 102 millimeters. And we'll check the warm in tube 1, or not the warm, the hot in tube 1. And that is still at 0. And lastly, the cold tube. 1 is still at 0. All right, so that is our data. The one questionable thing is whether or not we can trust this reading of 102. And a little asterisk next to that, so we remember that that is a questionable reading. And then I also want to get some temperature data to see how much the temperature of these different environments change. So the hot environment right now is at 54 degrees Celsius. The warm environment is now at 34 degrees. And in the cold environment is still at 4 degrees. Well, actually, it's a little colder now, 4.4. So we're going to round that off to 4 degrees. And one other thing I'm going to do, so here is our data for these different tubes. One last thing I'm going to do, I'm going to let these tubes sit out at room temperature for a little while longer, okay? So we have what was the warm tube here, what was the hot tube here, tube 1, then what was the warm tube, tube 2, and what was the cold tube, tube 3. And I'm just going to let them sit for a good 15 or 20 minutes more here, and we'll see what they look like. Okay, it's been about 25 minutes since the experiment, the official experiment finished, but we just took everything out of their different temperature environments to see what would happen. And as we can see, the one that was in the warm environment is continuing to ferment and kind of making a mess that the lab assistants and I will have to clean up. The tube that was in the hot environment, the 70 degree to 54 degree, it's still at 0. So there's been no fermentation in that tube at all. And then the tube that was in the cold environment and we allowed to warm up, that has about, I'm gonna say about 16 millimeters of displacement. So once this warmed up, it was able to ferment, but when the hot tube cooled down, it was not able to ferment. So that is a little bit of a puzzle for you to ponder. All right, well, this concludes the lab exercise 2 for lab 7, the fermentation lab. Ideally, we would have had replication. We would have had at least 3 of each of these tubes to get a sense of the variation between tubes in this environment and to make sure that it wasn't just a fluke that the results turned out this way. Unfortunately, I only have the 3 tubes, and so we kind of had to run this in not ideal conditions, and we're probably all used to not ideal circumstances by now. Anyhow, take care, and yeah, best of luck.